1.4, writing equations and inequalities. So we look at the vocabulary for this, the start, which remember you're writing with me. We have our little, talked about making these 2-column notes right here. Equation, let me give an example. X plus 6 equals 11. We've talked about expressions. Expressions would just be like the x plus 6, but an equation has an equal sign. And I remember that because equal and equation are spelled with the same, the first 4 letters are the same. So equations are, is a mathematical sentence formed with an equal sign. Okay, and inequality is a mathematical sentence that is formed with a less than, a greater than, or an equal. No, a less than or a greater than, or you can use less than or equal to, less than or equal, and greater than or equal. And that's what that sign means, and that's my tablet not working right here. That would have an equal under it. That's what the line means underneath it, is that it would be equal. An open sentence, and I'm on page 21 in your book. You're not there yet, page 1.4. An open sentence is an equation or an equality that contains an algebraic sentence. An open sentence is an equation or inequality that contains an algebraic expression. Let me see if I can come up with an example of one of those. So if you look, if I can, if my pen will write. Let me see. X, an open equation, is an equation or an equality that contains an algebraic expression. I believe that's what this would be. That's an open one. That's an algebraic equation. Solution of an equation, that's pretty easy. That's the answer. Okay, and the same thing on the solution to an inequality. So if it says find the solution of the equation, it means find the answer, find the missing part, find what number the letter should be. So let's go on to some examples. Example number 1 has us talking about verbal sentences, and there's also in the key concept box, if you guys will look on page 21, there's some other words. You know, equal, another word for equal is the same as. We have less than would be fewer than. Greater than would be more than. So you can see some of those words to be familiar with those. So a verbal sentence, the first one, the difference of twice a number k and 8 is 12. Well, you know, since this is a sentence, the is going to be different. The is where there's equals. So you know that it's going to be an equation right here. The difference of twice a number, so we do twice a number, 2k, minus 8, since the difference means to subtract, is 12. And then, of course, my pen doesn't want to work, is 12. Isn't that amazing? It works perfect, and then all of a sudden it just stops. I'm not really sure what the deal is there. So, okay, B. The product of 6 and a number n is at least 24. So 6n would be 6n. It's got to be at least that. So it's got to be, if you look at the words up above, at least would be greater than. It's got to be at least, so it means it has to be at least that. So it's got to be greater than 24. At least 24, I believe, would be greater than or equal to, because if it's at least 24, it could be 24. So we have to put the equal to. So let's see if that's, I agree, yep. A number y is no less than 5 and no more than 13. So that's going to be a 2 inequalities. Here we have y right here. And it's got to be no less than 5. So y has to be number 5 goes here. No more than 13. So it could be no more than 13. So this is called a compound inequality. In compound inequalities, you always have less thans. The smaller number always goes to the left. The bigger number always goes to the right. And we'll get better with them the more that we do of those. Okay, so our guided practice for number 1, write an equation or an inequality. The quotient of a number p and 12 is at least 30. Quotient means to divide, and I always do, so p and 12, p divided by 12, is at least greater than or equal to 30. And there's that word at least. If you look in the table on page 21, you will see that's greater than or equal to. And let's see if I have a solution. There it is. Check whether 3 is a solution of the inequality or the equation or the inequality. So we're going to substitute 3 in and see if it works. So the first thing we do right here is we can see, let's see if I can write it above a little bit so I can do it. 8 minus I'm telling you, 8 minus, I don't know what I'm doing, why 8 minus, why it does this. Well, I guess I'm not going to write, we'll just let them do the writing. 8 minus 2x, I put the 3 in, and we solve it. 2 does equal 2, unless you do this order of operations first, which would be 6. Wow. I don't know. The deal is with the pen. It would be 6 right here, and 8 minus 6 is 2. Sorry, I know that's got to be annoying for you guys. I will try to get that fixed. All right, this one. We'll substitute, I'll try it again. We'll substitute 3 in. Oh, all I can do is laugh because this makes me want to scream. See, I just don't get the secret to this pen action here. 4. See, and when I scribble, it works fine. 4x minus 5. 4 times 3 minus 5. 12 minus 5 is 7. And it says here it was 6. So it is not a solution. Let's look at that and see. Nope, that one worked. Get rid of all those scribbles, sorry. Alright, so we have 2z, this time this is an inequality, greater than 12, so 2 times z, 2 times 3, plus 5 has to be greater than 12. Well, 2 times 3 is 6, plus 5 is 11. Is 11 greater than 12? No. So we would say, no, it is not a solution. And I'm very verbal, I like to say them out loud. It makes sense if I say it to myself. And it comes out, we got the same thing there. Okay, rid of some ink here. Another one, this is less than or equal, so we have 5 plus 3 times 3 is 9. I get 14 is less than or equal to 20. Well, it said or, so it is less than, so we would say yes. I'll just leave that. Yes, it is a solution. And it is. So use mental math to solve an equation. So when we're solving equations, we like to think of a question. So in this equation, I'm going to say it out loud. X plus 4 equals 10. And I need to think to myself, what number added to 4 makes 10? Well, you think it. I think I've asked a question, and just knowing my facts, I know the answer is 6. 20 minus y equals 8. What number do you take away from 20 that would give you 8? I know that's 12. See, just basic facts, think of it as a question. So here's their question. 20 minus what number equals 8? The answer is 12, and then they check it. You put it back in, and you see that it makes sense. What number times n? What number times n is 42? There's my question. And 7. And it checks. What number divided by 5 is 9? So, in other words, what number can 5 go into 9 times? And the opposite of dividing is multiplying. So 45. Ooh. Don't know. 45. Boy, I can't write worth a darn. Okay, the guided practice for examples 1 and 2. Check whether the given number is a solution of the equation or the inequality. So the given number is right here, this 5. By this symbol, we're going to substitute it in, and we're going to say, does it work? 9 minus 5 is 4. And it comes out to be 4 equals 4. So yes, it is a solution. The next one, get rid of the ink here. 7. We substitute in 7 right here. So I get 7, maybe. I get 7 plus 5. I don't get anything. The pen is not going to work. 7. Stop. See, when I scribble, why does it work? 7. Let's see what the secret is here. Okay, I'll just talk it. 7 plus 5 is 12, and 12 is less than 15. So yes, that's a solution. Next one. 2n plus 3 is greater than or equal to 21, and there's the 9. I'm going to substitute. I'm going to substitute in 9 right here. So I'm going to go, no, sorry. I'm going to substitute in 9 right there. And I'm going to go 2, well, 2 times 2, man, 2 times 9, well, that's not going to work for me, is 18 plus 3. This comes out to be 21, and 21 is greater than or equal to 21, and we say yes, it is equal to it, so it is a solution. Okay, guided practice, solve the equation using mental math. Again, I ask myself a question. M plus 6 equals 11. What number plus 6 makes 11? And that would be 5. Oh, see, and then it writes. Amazing. What number times 5 is 40? 8. What number divided by 4 is 10? Or what number can 4 go into 10 times? That would be 40. And mental math to me is just facts. Okay, example 4, solving a multi-step problem. The last time you and 3 friends went on a mountain bike park, you got a coupon for $10 off and paid $17 for 4 tickets. What is the regular price of 4 tickets? If you pay the regular price this time and share it equally, how much does each person pay? So we go regular price. Find the thing. The regular price, in the book they're using P to stand for regular price, minus your $10 coupon left you, oh, I cannot believe this. I don't know what I'm doing wrong. Left you with minus 10 leaves you with $17. Oh, terrible. I'm going to have to stop after this one for a while. Write a verbal model. Let P be the regular price of 4 tickets. So, see right here. P, that's what I was trying to write. Use mental math because, 27, so it would be $27 would be the regular price for 4 tickets. So if you're going to share it equally to find the cost per person, you would take the $27 right here and divide it by 4. See if my pen works. 4 into 27 goes Set in 6 times, which is 24. There'd be 3 left over. Add a 0. My pin doesn't want to work, so I'll just stop. $6.75 per person. Example 5, basketball player. A basketball player scored 351 points last year. If the player plays 18 games this year, will an average of 20 points per game be enough to beat last year's total? Well, if they play 18 games and score 20 points a game, that would just be 20 times 18. So it will not write 20 times 18. I'm trying to push harder, I'm trying to push lighter. Nothing. 0. Wow. Okay, let's see what they did. An average of 20 would be enough because here they did 18 times 20 is 360, and they scored 351 that last year. So it would be enough for them to make it. I'll say, okay, in the last, the guided practice says, what if, in example 4, suppose the price of $4 tickets with a half off coupon is $15. What does each person share if you pay full price? So we have a half off ticket, in this case. I can't write my pen. 4 tickets with a half off coupon is $15. So half off would be, the original price would be 30 if you got half of it off, and you divide it by 4, and 30 divided by 4 then comes out to be $7.50. What if in example 5, suppose the player plays 16 games, would an average of 22 points be enough? 16 times 22 . 362, and if I remember right, they scored 351. So yes, it would be enough for them to break their scoring record. Okay, sorry about the pen. Didn't work very well, but hopefully you got the idea, and you can go on to the next, work on the lesson. See you next time.